Hello, I'm going to go through the answers to these density calculations. You might notice here in the triangle that they use this symbol. Looks like a P, it's actually rho. So if I was to draw it, it looks like that. It means density. So in the PowerPoint where it uses D for density, the actual symbol is rho. It's up to you which one you use. I mean, if you're going to do A-level physics and carry on, you should really start using rho, otherwise you'll get confused at A-level physics. Okay, so the first questions are converting different units into the standard unit. So if you want to convert 100 grams into kilograms, you divide by 1,000. So 100 divided by 1,000, which is 0.1 kilograms. Next is 100 millimeters into meters. So there's 1,000 millimeters in a meter. So again, you're going to do 100 divided by 1,000, which is 0.1 meters. Okay, 400 centimeters into a meter. There's 100 centimeters in a meter. So you're going to do 400 divided by 100 this time, which is 4 meters. Next, we've got some grams into kilograms again. So you divide by 1,000, so 2,375 divided by 1,000 is 2.375 kilograms. Got centimetres into metres here, 100 centimetres in a metre, so you've got 5,000 divided by 100, which is 50 metres. Okay, and then you've got millimetres into metres, there's 1,000 millimetres in a metre, so you do 64 divided by 1,000, which is 0.064 metres. Okay. Question 2, you've got a rectangular brick and it's got those dimensions and it has a mass of 2.5 kilograms. Calculate its volume and its density. So if we do the volume in centimetres, it will be these three things multiplied together. So 5 by 8 by 20. So 5 by 8 by 20 is 800 centimetres cubed. If you do it in metres cubed, okay, you need to convert these into metres. So that's 0.05 times 0.08 times 0.20, okay, which is 8 times 10 to the minus 4 metres cubed. Now, as a physicist, I would always put things into metres cubed and kilograms, but you just need to check what unit the question wants in, and this one doesn't tell us, so I'm going to do both. Okay, density, if we go to our triangle, is mass divided by volume. Okay, so the mass is 2.5 and it's in kilograms. If we divide it by this, 800, we get 3125, and the unit of that would be kilograms per centimetre cubed. If we do the same calculation but divide by metres cubed, we get 3,000. Oh no, sorry, I did this one wrong. This one's 3,125 kilograms per metre cubed. This one, sorry, you probably looked at that and gone, miss, you've gone wrong. It's 3.125 times 10 to the minus 3. Okay, and that will be kilogram per centimetre cubed. That's the answer really we're looking for, kilograms per metre cubed. Okay, question 3. We've got a solid steel cylinder and it has a diameter of 12 centimetres and a length of 85 centimetres. Calculate its volume. Now, the volume of a cylinder you should be able to figure out in maths. You want this area here, which is pi r squared, and then you can multiply that by the length here. So our volume is going to be pi r squared, okay, times the length. Now I'm going to do this in metres because I haven't got a lot of space and that's really the answer I want. So if you've done it in centimetres, just do it in metres now and see if you get the same answer. Okay, so we're going to do pi times, the diameter is 12, okay, so half of that would be the radius, which is 6 centimetres, 0.06 metres, squared, don't forget to square it, times the length in metres, 0.85. Okay, so that equals, just check this, okay, 9.613 times 10 to the minus 3 metres cubed. And now we need to calculate its mass when the density is this, okay, so kilograms, and we've got metres cubed, so we're going to use this answer. Go back to our triangle. Mass is density times volume. So we're going to do 7,800 times the answer we calculated before, which gives me an answer of 75 kilograms. Two significant figures. Okay, question 4. You've got a 100 centimetre cubed sample of ethanol and it has a mass of 78.9 grams. Calculate its density. I'm going to calculate density in kilograms per metre cubed. So 100 centimetres cubed, and we've got to go to metres cubed. Now there are 1,000,000 centimetres cubed in a metres cubed, and I've got 100 here. Okay, so what I'm going to do to work out my volume in metres cubed, I'm going to do 100 divided by 1,000,000. 1, 2, 3, 4, 5, 6. Okay, cancel out the zeros. Okay, and my answer for that is 1 times 10 to the minus 4 metres cubed. I'm going to calculate density now. Density is mass divided by volume. Want my mass in kilograms, that's 78.9 divided by 1,000. Now 78.9 divided by 1,000 is 0.0789. Now, if you're good at standard form, what you can do is, wherever it says grams, if you do 78.9 and then instead of grams write 10 to the minus 3, that means you're already dividing by 1,000. So it's exactly the same as writing this. So it's up to you which one you prefer. Then I divide by my volume, 1 times 10 to the minus 4, which gives me an answer of 789 kilograms per metre cubed. So this is probably a metal, it's quite heavy. Okay. Right, let's look at question 5. We've got the density of mercury is 13,600 kilograms per metre cubed. What is the mass of 20 metres cubed? So we want mass. Mass is density times volume. So I'm going to do 13,600 times 20, which gives me an answer of 2.72 times 10 to the 5 kilograms. Oh, that's really heavy. 13,600 kilograms per metre cubed. So a metre cubed of water weighs 1,000 kilograms. So it's 13 times heavier than water. It's probably quite dense. Okay, so dense mercury is really dense. Right, next, the science lab is 8 by 5 by 4. Okay, 8 by 5 by 4, and has a volume of 160 metres cubed. How much? how many kilograms of air does this room contain? And it gives us the density. So we know the density is 1.3 kilograms per metre cubed. Okay. It tells us the volume. I don't know why they've told us this, probably to confuse you. Volume is 160 metres cubed. So mass is density times volume. So you just do 1.3 times 160 which gives you an answer of 208 kilograms. Number 7, what volume would 5 kilograms of air occupy? Well, we know the mass is 5. We know the density from the previous question, so that's from there. That's 1.3 kilograms per metre cubed. If we go back to our equation, we want volume, it's mass divided by density. So volume is mass divided by density. So that's 5 divided by 1.3. They're all in the same unit, so that works. And that gives me an answer of 3.8 metres cubed. It says question 8 is a challenge. Let's have a little look. Let's lift this up a bit. Okay, for 8. We've got an empty paint tin of diameter 1.5 times 10 to, no, 1.50. So as we know from the previous question, the volume of this is going to be the area times the height. It says it has a mass of 0.22 kilograms, but it says it's filled with paint to within 7 millimeters of the top. So that's my line there. And its total mass is then 6.5 times kilograms. Calculate for the paint in the tin. So we're only interested in the paint. So the mass. So if the total mass is 6.50 and we know that the tin has a mass of 0.22, if we take the mass of the tin away from the total mass, that will tell us the mass of the paint. So the mass of the paint is going to be 6.28 kilograms. Now the volume. Now we're only interested in the volume of paint. So what we need to do is do something with this length, because we don't want the length all the way to the top, we only want the length of the paint. So the length of paint will be the total height, so that's 0.20120. Take away 7 millimeters, because it says it's 7 millimeters from the top. So that's 0.007. That gives me an answer of 0.113 meters. Then to do the volume, you do the area of the top, so that's going to be pi r squared times that length. It tells me the diameter here is 0.150, so I need half of that for the radius. So the radius is going to be 0.150 over 2, okay, which is 0.075 meters. So I'm going to substitute all of this in. So I've got pi, I've got my radius here, 0.075 squared, times my length here, 0.113. And that gives me a volume of paint of 2.0 times 10 to the minus 3 meters cubed. I can now calculate the density. So the density is mass divided by volume. So I want the mass of the paint and the volume of the paint. So the mass of the paint is here, 6.28, and the volume of the paint, 2.0 times 10 to the minus 3, which gives me an answer of 3,140 kilograms per meter cubed. Okay, hope you found those okay. Any that you struggle with, just let me know. Please can you upload an image of your purple penned answers just so I can keep track of who's doing what. And yeah, thank you. Bye.